right, here we go. We are going to talk about today composite functions, okay? So we are going to use our inputs and output property like crazy, okay? So again, we're focusing on the word evaluate, so we are looking for an answer. The problem is we have a function embedded into another function. Okay, that's the actual definition of composite functions, or functions within a function. This little buddy right here that you can't see because my printer ran out of colored ink is a present. And if you think of composite functions like a present, on the outside here we have the bow, right? Got to take care of the bow first. Then in order to get your present, you have to get rid of the wrapping paper, right? And then to actually get what's inside is like our little, oh, I don't know, a toy. What should our toy be? Well, right now it's nothing. Okay, so but inside, in order to get into that, we have to deal with the outside first. So composite functions, we can do that with the same idea as a present. Okay, there's two ways of writing composite functions, knowing that we are looking to substitute another function in for x. So my highlighters are stuck in this box, which is super fun, but here we are. Okay, so I'm going to substitute a function in for an unknown in a different function, right? Kind of sounds crazy. So it looks like this. So we have f parentheses g parentheses x, option number one, or f dot g of x, okay? They are both read as f of g of x. And this guy, which can't really tell what it says either, says these buddies mean the same thing. Okay, so the deal is that we would read this as f of g of x, f of g of x. We have to be super careful that when we are doing composite functions, we are reading left to right. Okay, the guy that's inside is going to be the function that you input to the big outside guy, right? The present is inside the box. So the outside piece of the box, the present, the toy, the whatever is deep inside, okay? So we have an example. Let's scooch it up here, hold on. Okay, that looks like this, okay? Here are my two functions. I have an f function, I have a g function, and we are gonna evaluate f of g of 2, okay? So we start on the inside of our box. We're wrapping up our present. So I'm gonna input the number 2 into my g function. Okay, so we're over at my g function. Whoops. And I'm going to input the number 2 in for x. Okay, so I'm going to get g of 2 is equal to 2 squared minus 2 minus 1 equals 4 minus 2 minus 1 is equal to 1. Whoops, sorry guys. Okay, so that means this g of 2 is really 1. Now we go to the outside of my present, which is my f function, okay? So now I'm going to have f of 1. So I come over to my f function, and I'm going to substitute in what I just figured out from my g function, which was 1. And now I'm going to have f of 1 equals 2 times 1 plus 4. So f of 1 equals 2 plus 4. Whoops. So f of 1 equals 6. So final answer, f of g of 2 is equal to 6. Composition function example. Oops, sorry buddies. Number 1. All right, hold on here. Okay, so we have example number 2. What I did is I did a little highlighting already. Okay, so my g function is 2x plus 3. My h function is 5x minus 1. Okay, we're going to do two different, I'll do one, then you guys can try one. But g of h of x, okay, so we're taking the outside box is your g function, your present is your h function. When there's x's left in there, that means you are not going to get a number, right? When my final input is, we'll call it quote x, your answer is an expression. Okay, so don't panic that you got to get a number. Okay, so here we go. Take my h function, taking my present, and I'm putting it in for my input of the other function. So I've got 2 times my h function, 5x minus 1, close that buddy up, plus 3. So 10x minus 2 plus 3 through a little distribution. Simplify her up. 10x plus 1 through combining like terms. Okay? All right, now you guys try problem number 2. Be back in a flash with the answer. All right, answer to the next one. Took my g function, 2x plus 3, plugged it in for x of my h function. So 5 times 2x plus 3 minus 1. Final answer, 10x plus 14. All right, so now we have 2 new functions. We have our h function and we have our g function. Those are my friends in the back in the kitchen who are arguing, so they're super nice sometimes. Okay, so we're gonna take my h function, this guy number 1, take my h function, and I'm gonna plug in g, but I'm careful of that little exponent right there, okay? So I'm gonna have my g function goes in for x 2 times, x plus 1 being squared from my original h function, plus, again from the original, x plus 1. Okay, don't forget, when something is being squared, that means that's got an extra 1 there. Have to write it out twice and look to FOIL. Okay. Final answer, when you substitute a function into another function twice. Again, we took our g function and substituted it in for both x's of my original function. All right, last example here, those 2 same functions for sake of time. H of 3, plug 3 in for my h function. 3 squared plus 3 is 9, plus 3 is 12. Then took my 12 and plugged it in for my g function to get 12 plus 1 for a total of 13. All right, kiddos, hope that all makes sense. And your little assignment in Google Form will be on the classroom. Hope you're all safe and hanging in there. See you guys.